Hello everyone, welcome back. This is part 2 of the decentralized to-do app tutorial. And today I want to go over namespaces and encryption. What I'm going to be showing you is kind of a naive way to implement this. We're basically going to be creating a user that represents your app, and then you'll be able to give the login keys to anyone that you want to be able to use the app with. So for example, you can create a to-do list for your family and then just give out the access keys to every member of your family, and then they can use it with you. So that's what I mean when I say it's kind of naive. It's just one key for the one list. Okay, so that's what we'll be doing here. So that involves namespacing and encryption. So namespacing is going to be a let me just put this up on the screen. Namespacing is going to be a flow that kind of blocks users from writing to a certain node on the gun graph. So when we create a new gun.user for a specific to-do list, then you will only be able to write or add or update or delete items if you are logged in as the correct user. If you're not, that verification won't go through and it'll block. So the flow I have on the screen is like sort of correct. I think the signing and verifying is actually both on the top line now that I think of it. But that doesn't actually stop here. That doesn't actually stop you from reading the data. So what we also want to do is we want to implement encryption. Okay, so if we have namespaces and encryption, then only your user login can write to the data, update the data, and only you can read the data as well. Okay, so that'll cover both aspects, and that's going to use gun.user API, and it's going to use the SEAC API as well. Both are kind of included in the gun ecosystem, as we'll see. So to start off with, I want to walk through where we left off last time. I made some updates to the code here. I added updating timestamps. And so, for example, every time you change the status, it will update the date. So I changed this to last updated. So that's kind of a nice little feature where you can see how recent the last change was. For example, you could also do something like created date and then also last updated date. So you could see the differential of time there, how long it took something to be completed, for example. We won't worry about that for now. And then I also added some security fixes in the render function where Mark actually pointed out that someone could type in a JavaScript script and execute it if you just did inner HTML. So we had to change that to inner text, and then we made it so we built this up over a number of lines and then kind of added it together. So you can see that code online then. Yeah, and that's the bulk of the changes I made. I also made some little rendering changes where the list itself is a little bit cleaner. So I'll just like briefly show how that works. So you can see that the layout is a little bit better, where you have the LI is that whole block, and within that we have the actual text, and then in small letters the time, and then the buttons are in their own little div here, right? So just a little bit of a layout change there as well. Now, just to refresh as well, this data here where we left off, this is totally public. Okay, anybody can write to this and anybody can read from it. So if I go to REPL it, that shows up over here. And I can change the status and that shows up over there. It's a cool functionality, but it's not very practical, right? So firstly, we're going to implement those namespaces that I talked about. So I got to go back to the code here. So the number one thing we want to do to set ourselves up for success with the namespaces is we want to add a splash screen. So I did that first. We're kind of baby stepping our way through this. So the biggest changes in this code here are going to be the addition of a start function and a new app function. And also the HTML structure changes. So this is, we're using plain HTML and JavaScript to add a basic kind of routing functionality. So we have a splash view and we have an app view, right? And at the beginning of when you load the page, the app view is going to be hidden, right? Because we don't actually know what we want to load quite yet. And then the splash view is going to show up, which is going to have a button where you can click to create a new app, okay? So when someone clicks on new app, all it's going to do is say creating your new app, and it's going to call the start function. And in start, we actually moved our listener inside of start, because what we do in the start function is we actually assign GunApp graph to the correct graph here, or graph node here, and then we also put the listener here. Because if we actually put the listener outside where it used to be, the on listener would be defined on this thing here, right? So we actually need it to go inside of the start, because we want to define it to that so that the on listener actually is working correctly. So it listens on the right things. And then after we define the listener, then we're going to simply show the app by deleting this. We delete this style display none, so then it displays the app, and then we are going to add display none to the splash view here. So we're just kind of switching which ones show on the screen. So I'll show that on the browser here. Got to refresh the page here. So create new to-do list. There we go. So it's the same underlying code where the data is global read-write to anyone that wants to, right? The difference is that we have our splash screen in here. So when I click on create new to-do list, if I scroll up at least, it'll say creating your new app, and then it starts to do the work, right? So now that we have our splash screen kind of code structure there, we want to actually add in the namespace code. So we've kind of set ourselves up for success here by adding in the splash screen function. So you can see right away that we have the same button, create new to-do list, but we also added a existing to-do thing here as well. So we can recover a different namespace. So let's go back to the code and look at how the namespace code works. So we have our start and we have our new app, but we also have getApp, right? So let's look at how start and new app have changed from just the plain splash screen. So there. So when we called new app from that button, all we did was console log, and then we called start. Now, what we're going to do is we console log and we call start, but we also say app keys equal await c.pair, and then user auth app keys. Okay, so let's talk a little bit about what this is. So c.pair, what this does is this. Well, firstly, we actually include C in our code, so you need to make sure that the script is now included there, so you can see that. So that's going to be our cryptography functions, and c.pair is going to give you a key pair that is basically like it's an object, and it's going to have pub. So that's your public key, your private key, your EPUB and your EPRIV. Now, your public key you can kind of think of as your username. Your private key is going to be like your password. And then these two are typically used, like if somebody wants to send me a secret message, then they would use my EPUB. And if I want to encrypt a secret message for someone else, I'm going to use my EPRIV. But for simplicity's sake, what we're going to do is just kind of pass around our app keys as a whole unit. And that's going to be our entire login. So this is kind of a naive implementation where we're just kind of passing around a whole key pair, and that's just going to be our one user and password, okay, just for simplicity's sake. All right, so that's what c.pair does. Is it's going to be a function that assigns app to app keys, that kind of structure. And then I'm going to call user.auth app keys, and you can see here var user equals gun.user. Now user.auth, all it's going to do is kind of add my user onto the global gun system, and then after I do user auth, I'm going to be able to later on use those same app keys to recover a to-do app that I've created. So if I log in later, I'm going to do user auth and then my previous keys, for example. So when I call start, then up here, I want to firstly say, all right, only build the app if my user is logged in. And a convenience function for that is user.is. And that's going to return true if I'm correctly logged in or not, okay? And then it's going to print out my app keys to the console. That's just for me, so I can copy them and save them later. And then like before, it's doing the GunApp graph stuff and the show hide, just like the splash screen before. Now, the other thing I added was the getApp, right? So on the home screen, you'll see existing to do here. So for example, if I did create new, and I can see my app keys printed from the start function, right? So I'll add some things, 1, 2, 3, right? Now I'm gonna go up here and I'm gonna copy this to my clipboard. This is my whole, what we call a key pair, right? Even though it's 4 things, it's a key pair. And then I can refresh, and in the existing to-do, I'll paste my key pair, just like that, and it recovers my old list, the same thing. Pretty cool, right? Now, what this allows us to do is, if I, from Replit, for example, if I try to add data using gun directly, it won't let me. So for example, if I do, I guess I should say the getApp, all the getApp is doing is saying, okay, grab the app keys from the input up here, grab the app keys from that, empty it out, and empty out the input, and then do user auth app keys. So it's very similar, just a slightly different flow. So what namespacing allows us to do, I'll show you right now how this works. Oh, whoops, I wasn't showing the code when I was walking through that. My bad. But yeah, I just said like getApp, the input up here. All it's doing is a slightly different flow where you have it grab the app keys from the input and then also do user auth, same basic thing. So you can look at the code on the GitHub link that I'll include. So what it allows us to do then is, I have this example code here. So I'm going to show how namespacing works in practice. So I'll bring the browser back up, and so if I say gun.user with empty parentheses, this is going to basically be my local user. Okay, so it's gonna be my key pair here, right? that I'm logged in as currently. I could also, because of the way the app code works, I could also just say user.get because I have that in the code as a variable. But for now, I'll just do gun.user.get to-dos, right? And .put, I'm going to just put this here. Hi from some random person. And you'll see there's something wrong with, there's something that's undefined, like the thing is not working for me. And I'm not sure if it's the way that I structured my code or not. But anyway, the point is I can write to this, right? That's the point. Okay. Now, if I go over to REPL it, for example, in this one, and I try to do the same thing where I actually say, I actually even could grab my public key. Oh, actually, I only want the public key, so I'll just grab this top part here. And from this other user, if I say, oops, can I not, oh, maybe I should refresh and see if it, REPL it is struggling right now. Okay. Okay, well, there's my public key. I gotta copy this again. All right. Boom. Okay. So copy it this time. Copy. Why won't REPL it let me? This is terrible. I guess I'll just do it manually here. Paste. All right. There. Oh, gun.user is not a function. Oh, I gotta update the code in here. Okay. Now this time I will be able to show you guys how this works. So I'm gonna grab the public key, copy, paste that in. Oops. So over here it lets me write things to it, right? But if I try to do the same thing when I'm logged in on REPL it as someone else, it won't let me. Yeah, here it's basically blocking me out here. So if I go and look back, nothing was added, right? These undefineds were there before. So that's what a namespace allows us to do, essentially. Now I want to go on to, I think encryption is the next step here, right? Okay, so hopefully this makes sense how namespacing works, but the problem is that if I wanted to read the data from a different user, I could do that. So if in my REPL it user I did getTodos.map.onThing, console log, I could actually read all of the data because it's still public, right? So namespacing is basically the equivalent of like an unlisted YouTube video, for example, where if someone has the URL, they can see the video, right? But encryption and decryption is going to be more like password protection, right? Rather than just unlisting. So I'll go over to that code now. Now, with the encryption and decryption, quite a lot changes. So hopefully you have a grasp of these 3 new functions that we added. So 1.8, encryption and decryption. Nothing changes up here at the top, okay? If I go down here though, we'll see that I think I added here, no, C was, I think C was there before, maybe not. But basically with encryption, I think I showed the flow already, but I'll put it up on the screen again. So when you're thinking about how to encrypt and decrypt data, you need to think about how to structure, like where do you actually need the encryption and the decryption functions to live, right? So we know that when we add a to-do, when we edit, or when we delete a to-do, we need all of those data payloads to be encrypted before they reach the gun graph, okay? So we could add a helper function, but for the sake of simplicity, I just put an encrypt, a c.encrypt function inside of add, edit, and delete, okay? So in the add to do, change status, and delete thing functions. Now, when we decrypt the data, that's going to be whenever we get an update from gun, we need that update to be decrypted because it's always going to be encrypted. Okay. So looking at the code here, well, let's look at what that is in practice. So in add to do, we're going to have encryption right here. So now we have it defined where here's data, and we could call it like plain text, clear text data, for example. But then we have var encrypted data, await c.encrypt data, and app keys, right? We're encrypting it with our app keys, okay? So this is like password protection, right? And then I have a bunch of console logs that say things like encrypting it before sending, and we'll show what the encrypted data looks like. And then we'll actually send the encrypted data to the gun app graph. Now, it's pretty cool. Like, we can actually encrypt an entire JavaScript object, right? Like JSON, and send that over. So you can encrypt more than just like text, for example. And then the same thing in change status and delete. So like with delete, we're actually encrypting the null value, and that's just for the sake of being holistic, right? Like null doesn't contain any special significant information that's like very private, but we just want to be holistic where like if somebody is listening to our activity, we don't want them to necessarily know that we are specifically deleting something. So to them, it just looks like some encrypted payload like usual, right? So we encrypt that, and we log it, and we send it as well with a put encrypted data. So this is basically put null, right? And then with change, we actually had to do something a little bit different where previously we could update just the status and the last updated time, and it would keep the thing from before. But now we actually need to include the thing manually, because what we're doing is we're putting the encrypted data, which actually overwrites the entire old object. Whereas last time when it was in clear text, it would only update what we sent, and then it would just keep the old value from before. So we need to send all three because we're encrypting it now. So we send that updated payload there, we encrypt it, and we put the encrypted data. Okay. Now looking back at our encrypted flow here, so we are encrypting it before we're sending it to gun. Okay. So now we need to decrypt it after we get it back. So where would that be? That would be on the listener, right? On the listener function. So in our code, let's go up and look at where that listener function lives now. So ignoring the render list. So it's going to be in our start function, if you remember. So gunappgraph.map.on. So this is how we listen for updates. It's in our start function, right? So this time we're actually, rather than, if we go back and look at our old start function, rather than listening and grabbing node and node ID in this listener, I actually renamed it to encrypted node and node ID. So the node ID is not encrypted, right? But the encrypted, the node under the node underneath the node ID is. So I called it encrypted node. So that might make it a little more clear in the code. So I have it now printing, I just got some encrypted data. Here's what it looks like. And we're going to decrypt it with our app keys, right? which we're currently logged in with, right? App keys. Alternatively, instead of app keys, you actually could write user.is.alias. But for the sake of simplicity, we just want to use that local variable, which is app keys. And then I say, here it is decrypted, and then updating local data. So we set the decrypted node and node ID to the local data, then we render it as per usual. So if we handle this decryption in the listener, then our render function isn't affected, right? We're able to maintain our nice little structure here. So let's go and look at that in practice here in the browser. Encrypt, decrypt, okay. So I'll just refresh this, create new to do, creating your app keys are here. Now we'll do thing to do, 1, right? You'll notice that it took a little bit longer this time, 2, 3, but afterwards it kind of does it quickly. So we can see an example here where, let's go up to the top of this. So it says setting 1 to the gun graph, encrypting it before sending. It looks like this over the wire. So, and here's what it looks like encrypted. SEA, that's the name of the encryption library we're using. And then we have the name or the node ID. So this is what it looks like over the wire. And then gunappgraph.map.on says, oop, this was updated. I just got some encrypted data. Here's what it looks like. And it repeats for some reason. Let's ignore that for now though. And then it says, here it is decrypted, and here's our object. Just like before, it's just a JavaScript object. And then, as per usual, updating local data, re-rendering, blah, blah, blah. Cool. So that's all well and good. That's encryption, and it works for this as well, changing status. So even the status updates are encrypted. We can delete, and the puts are encrypted, right? So if people are sniffing for our activity, all they're going to see is a bunch of stuff like this. Right? So it doesn't make sense to them unless they have our app keys, which are here, okay? And we're currently logged in with them now. Okay, so let's go to the next step, which I actually, that's basically how encryption and decryption work. I wanted to do a little exercise now by adding an additional piece of data, which would be a way to name our to-do list. So actually I'm going to show the browser again just to show how this works. It's pretty cool. So now in here, when we do create a new to-do list, we can actually give it a name, and that name itself is going to be encrypted, okay? Or we can recover it by pasting our keys. So for example, I'll call this like Smith family list, right? And that's the name of our to-do list up here. We'll do buy milk and eggs, mow lawn, okay? Now to kind of display how this works, I'll copy, I'm gonna make sure I'm showing the right screen. I'll copy the key pair here, right? And I will log out basically by refreshing. By the way, I don't have, like, in the Edge browser, I don't have the ability to do local storage. I disabled it. So if I did like always allow setting of cookies, then I think it would allow the local storage, but by disallowing it, it's actually a little bit easier to test Gun. So I'm gonna leave it like this. So if I just do a quick refresh, it brings me back to the home page because my local storage doesn't work. So anyway, create a new, so I already have one. I'm going to paste the keys here, enter, and it brings up Smith family list, right? As well as the list. So let's think about how we can implement this in the code, right? So if you want, you can pause the video and just kind of think about what would be necessary to add another piece of encrypted data. Okay, I'm going to move on and just show you right now how I did it. So looking at the HTML, obviously we just added a little bit of a new structure at the top here in the splash screen. So we just added the ability to do, so new app is actually an input text box with a placeholder, right? Name the list, right? So it's going to pass in the element just like the recovery getApp. So looking at that, we're going to go down to new app here, and we want to say list name is that. So what we're actually doing is we're saying after we authorize, we do user auth app keys, we're going to say the encrypted name of the list is going to be list name, and we're going to use c.encrypt, right? And then we're simply going to put that encrypted name onto our user namespace graph, but it's not going to be user.getTodos, it's going to be getTodos.getName.put encrypted name, okay? And then we call start. Now, when we put something, we also want to have a way to listen for those changes, right? So in the start function, along with GunAppGraph listeners.on, we're also going to have a user.getTodos.getName listener, right? So every time this node changes, this listener here is going to execute, and what that's going to do is it's going to decrypt the payload that it gets, right, with C, and then it's going to set the name of the list just using the regular old HTML or regular old JavaScript method, right, where title inner text is going to be decrypted name, right? So that's how that works, but you'll notice that our graph structure has changed, right? So we not only have getTodos, we also have getName. So that means that we also want to change the GunApp graph to getTodos.getData. So now our graph overall, our app structure is going to be more like Todos, and then it's going to be like, oh, how would this be structured? Name is Smith family list, and then data is going to be an object with like nodes of data. Okay, so that's kind of the structure with how it is now. You can think of it like that. And because we set GunApp graph up here, it just makes it easier, so we don't have to totally change the rest of our code. We can just set it equal to this up here. So that's pretty much it. That is the bulk of the changes there. I'm going to link to the GitHub commits for all of these little stages that I changed the code in, so you can look at how things evolved over time, and that should really help you understand the gist of it. I have here in the done one, all I did was I took out all of the console logs, got rid of all the console logs. Oh, I guess I forgot a little semicolon there. And without the console logs, the whole thing ends up just being 127 lines. So we didn't even double it when we added in the encrypt and the namespace. So pretty awesome, if you ask me. So now going back to the browser, I can go to the final product here, and I'll just do create new list, my cool list, and I'll blah 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 blah, and I can change, delete, change. And if I go to the console up here, oh, I guess I have it in the final thing. I don't have it printing the keys anymore, which I need to do. So the next thing that you're going to want to think about is, well, firstly, I want to have it print the keys again, because I need that functionality back in. So I'll just go to the start, and where it prints the keys, I'll add these lines back into the done one here. Oh, also this is a line that I didn't want added right there. 43. Anyway, I don't know why I have that in there. It shouldn't be there. So the next thing that you want to think about is how to how to make the app a little bit more user-friendly. Like, what is a good pattern for sharing a key pair with people that you want to share it with? One thing that you could do is you could somehow put the key pair into the URL, and then you have a unique URL that you can share with family or friends, right? So then you don't need any kind of a login at all. You just have the key pair in the URL and you say, hey, bookmark this URL, and you can get into our shared to-do list. But another thing that we will probably do in the future is, in addition to the list having its own unique user, right? In addition to that, we actually want each individual user to have their own name as well. Me, you. So, for example, when I write things, I want it to say updated by me, Kale, right? And then when you write things, I want it to say updated by you, right? But in order to do that, we need our own key pairs, right? And then the list can have its own key pair as well. So the list key pair would be shared between us, and we would each have our own identities as well. So what that involves is just a little bit more advanced abstractions that we can build using these primitives that we've learned today. So thanks for watching. Comment if you have questions. I know this one moved a little bit quickly through these topics, but hopefully looking at the code on GitHub, you can learn a bit more. All right, thanks. Bye.